right, so very, very great to be here. Thank you so much. I'm Patrick Couch. I'm with Hewlett-Packard Enterprise, and I will give you a 20-minute blast of tokens. So buckle up and brace for impact, because they are shaping and reshaping how we think about setting up strategies and leveraging compute for AI. You may have seen this meme floating around the internet: AI costs versus human salaries, basically pointing to the fact that, hey, you know, these are the LLM API costs, the junior data scientist salary, and the conclusion is, welcome back to the team, Alex. Another thing that happened also recently was we got a new financial metric, which I thought was hilarious: the EBITDA, earnings before interests, taxes, tokens, depreciation, and amortization. So tokens are all over the place in the news, in the CIO suite. And did you see the news about Microsoft showing why the token focus is a problem for them? This was in the news the other week, and basically saying Microsoft realized that using the tech is more expensive than paying human employees. Which I thought was interesting, because we've always said that, no, but technology is coming for the jobs and AI is going to displace everybody and we need the universal basic income. But not so. Now, the reason for this is the token-based billing mechanism, right? And how many of you use GitHub Copilot to some extent? How many of you, keep your hands up, how many of you know what happened Monday? More people are using. Okay, so what happened Monday was that Microsoft switched over to a token-based commercial model for pricing out GitHub Copilot. So we are sort of in this interesting shift now where we're looking at tokens, and we're sort of using tokens as a mechanism for pricing out AI compute. Now, this is not that easy, because this was not the case before. We've always appreciated consumption-based models, you know, pay as you consume, which has always been sort of, that's nice, it has a certain appeal. But if you're Uber and you allocate a certain amount of budget for your AI compute, and then 4 months into that year, you have burnt the entire budget, because the uptake of the AI compute, all the use cases that people are churning out, are based on a per token commercial model, then you're in trouble. So then you're sort of back to the drawing board, and you're trying to figure out, what do we do now? Another fun thing that sort of is happening, or not, I mean, this is a lot of murky stuff happening on the internet out there, but basically the AI token freeloaders are coming for your customer support chatbots. You see this? And do you know why? Because users are tricking enterprise chatbots into performing complex AI computations unrelated to customer support, with potentially costly governance and ROI ramifications. It goes like this. Let's say you want to figure out something complex. You go to Amazon, you go to their customer chatbot Rufus, and you say, hey Rufus, I need to find a USB-C hub, which is fair, they sell that on AWS, on Amazon, but can't even think about it until I can craft a Go function to output the Fibonacci sequence up to n count. And the customer chatbots, they are very much your friends, so they try to appease you, and then they do that. All that compute you don't pay for. Anyway, this is not necessarily a very big problem, but it does point to the need for guardrails. However, what is, I think, very much of importance to figure or to be aware of is what came out of the NVIDIA GTC earlier this year, when NVIDIA Jensen was on stage, basically laying out the future for us. And there were a couple of things that he highlighted over that keynote. One was tokens as the commodity to define value, pricing, and competition. Number one. Number two, the AI factories with an eye to per watt AI performance, and these then in combination setting up the new AI operating model. And this, I think, is where the strategy side of this tokenomic thing is happening. So before we rush forward, maybe we should just ask ourselves, just what are tokens? And I don't know about you guys, and I'm not going to ask you, but I wonder how many of you are comfortable explaining to the person sitting next to you what tokens really are. I mean, it's a lame question to ask. I'm not going to ask it, but I will give you the answer so you can sort of do it next time. And that is, tokens are the smallest computational unit of AI, if you will, assuming we're talking LLM-based or transformer-based architectures. There are plenty of other kinds of AI, but that's not what we're talking about today. Today, we're talking about model-based LLMs. And for them, tokens are the smallest computational unit of AI. So for instance, if you think about a text, like a word, you can tokenize that into 1 token or 2 tokens. So you have database, one part of that word, data, is a token. If you have an image, a very small piece of that image is the token. Or if you have a sound wave, if the raw data is a sound, you have a slice of sound, that's the token. These are all stood up as numerical strings, because obviously we talk about natural language processing or natural language understanding. But machines don't understand language. They don't. They understand math and numbers. So we have to translate all that interesting data that we find interesting into something that the computers can compute. And that is done through a process called tokenization, which is basically this process of turning data into tokens. And once we have tokens, we have a commodity. We can trade it, we can transact it, we can measure it, we can count it, we can use it for all different things. So if you think about something like this, a sentence, tokenization is fascinating, which it is. An older model with a small vocabulary may tokenize that into a string of 8 tokens. But if you have a newer model with a larger vocabulary, it will be able to tokenize the same sentence into fewer tokens. And if the token is the carrier for the commercial pricing out of your compute, this is important. Because you've probably seen something like this. There's a couple of memes going on about, why would you use the frontier super costly but capable model to do something very simple at a very much higher cost? And you won't, or you shouldn't. So you need to be sort of figuring out how to navigate this, because there are very many different ways of standing up your AI compute stack. And if you want to dig into this, how sort of cost optimization relates to custom tokenizers, I recommend this blog published by Ellen Björnberg at Predly, a Swedish startup, which is really good. And I will send you, or those that are interested, all the links to these things that I am referring to. Underlying the pricing per token as a commercial model is the fact of the actual cost of compute. And you probably are quite aware of the fact that the largest part of that compute cost is the GPU. So the question is, how much does the GPU cost, and what does that tell you about the pricing for tokens? And that has given us this metric of the dollar per GPU hour. So if you go to a GPU farm or a data factory or an AI factory or a data center, maybe you can rent GPUs for certain dollars per GPU hour. And that will be dependent upon the kind of GPU, and that will be dependent upon the number of tokens the GPU can process. That ends us up in this wonderful world of optimization. And there are different ways of optimizing models and how models work. On that side, quantization is basically the most well-known one. Think of it in terms of compression, if you will. If you have a true tone audio file and you compress it into an MP3 file, or if you have a heavy-duty image and you compress it into JPEG, you're basically maintaining more or less the same kind of image, but at the lighter weight. There are some trade-offs. In our case, or in the image case, it may be the true granularity of the image, the number of pixels in the image, but for the model, it may be the accuracy in the prediction of the next token to produce. In a more novel area, we will find things like quantum-inspired optimization. But what this means for you is basically, once you are thinking about how to stand up your AI compute, what model to use, there are many different ways of finding or trying to figure out what the best model is. You can use the Swedish company Embeddel's services if you want to sort of optimize on latency. You can use another technology from Inceptron, another Swedish company. If you want to optimize on concurrency per GPU, you can lean on NVIDIA's NIM pipeline. If you want to maybe increase the number of tokens your IT estate can push through. Or you may lean on something more novel like Multiverse Computing out of Spain, which is a Spanish deep tech company that does some kind of quantum-inspired magic, which means that they can get rid of a lot of these parameters that drive the performance problematics for GPUs. The consequence of all of this that is relevant for you then is the challenge of the model selection. And I've been talking about AI for a long time, and I remember when Hugging Face first came about. And then there were like a few models on Hugging Face, a few hundreds, and then there were a few thousands. Now there are 3 million models to choose from on Hugging Face. And you guys need to figure out which one to use if you want to use something other than a black box proprietary model and ship off an API call to somebody else. So how do you do that? I mean, it's impossible, right? But that has triggered the surfacing of something very interesting, namely the LLM router. How many of you have heard about OpenRouter? Only a few. So OpenRouter is basically a switchboard that marries your inference request with a suitable inference provider. And so instead of asking you to tell somebody, I want this specific model, you basically say, hey, I want this inference request served, I want to pay this much money, and I want to be sovereign, and the first time to token is important to me. Apart from that, I don't care. And then OpenRouter and these other routers, they're figuring out how to match this. And onto that platform, a lot of inference providers list their per token prices based on different models. And there you have all these quantized models, all these quantum prune models, all the rest of them. So you don't need to worry about that. You just need to route your traffic to a router, and then the router will take care of it. Now, this has been very successful. So they have grown the past 6 months from 5 trillion to 25 trillion tokens processed per week. So the shift is towards indirect routing or indirect consumption of inferencing, right? So instead of going and swipe your card over at OpenAI for a specific model that you decide, you go to a router, then it takes care of that. Problem with OpenRouter for you guys may be that it is American. So there are alternatives. At the GTC a few months ago, there was an initiative by Iaxia, Evrock, and Opper announced called Build Nordics. And Opper is basically this API or AI gateway for agents. So it's similar to OpenRouter, but it's completely sovereign, it's completely under European jurisdiction, and you can be completely comfortable that you're abiding by whatever sovereignty aspects you need to abide by to be comfortable, to be aligned with your company policy. If you want to be even more strict and you want to keep within the national border of Sweden, you can go to a company like Berget AI, who are basically providing a similar type of routing service, but completely instantiated and incorporated in Sweden. And they are also using HP servers, by the way, just so you know. Underlying all of this token compute is basically the AI factory that Jensen spoke about. And this is something that I think the industry as a whole has embraced as a model. And this is something that is not unique to HPE. All other larger US tech companies sort of think along these lines because NVIDIA basically set the blueprint in place. But the reason why the AI factory has been embraced is because the factory is basically this amazing idea or method to instill on some madness. And preparing for this, I was looking into some numbers, and I came across a fun fact. You know the iPhone factory that Apple operates in China? At max capacity, they can churn out how many iPhones per day? 500,000. 500,000 iPhones they can ship every day at max capacity. Do you know how many out of those that they actually ship to end consumers are faulty in some way? 50. Or maybe 500. Between 50 and 500. So they can, by adopting Lean Six Sigma stuff, they can churn out product at an unprecedented level and at an unprecedented quality. Now we in the AI space, we also want to be able to do that. And we're trying to get there. And the way to get there is to start figuring out how to factorize or make into factories the production of intelligence. So when you churn out those insights, the customer services, the automated workflows in your back office or whatever it is that you are up to with your AI compute, this method is what you want to try and lock down. So basically you can input data, input models, you lean on compute, storage, network, power cooling, all the things that you need. You lean on observability, mechanisms, auditability things, control gauges. And if you do it correctly, you can basically be the Apple iPhone factory in China for yourself at the scale that is suitable and relevant to you. And at HPE, where I work, we have this broad portfolio of AI factory offerings, everything from very small turnkey solutions that is basically a handful of servers and a handful of servers, and then you just have it ordered and shipped from our European factory, and then you have a 3-day to first token processed mechanism at your hands. If you want to do something more complex or at scale, we also offer the services around the AI factory at scale. And if you want to go fully air-gapped or be fully sovereign or reside within your own firewall, but still compute AI, we can offer that as well. And we basically have these two offerings. The turnkey solution, which we are very proud of, and that the market has adopted and said, you are the best, which we like to hear. And then also we use local partners to be able to provide you guys sovereign AI factories to use for your own compute, either as managed services or instantiated on-prem with a commercial model that is relevant for you. Because what happens is, once you realize that you are actually paying for what you consume, and the token is the carrier, the measurement for that, it will be more important for you to be judgmental about, or have a judgment about how you compute and what you compute, because everything costs. But if you go on-prem or co-located or lean on a managed service provider, you can move away from a token-based commercial model into something that is perhaps more aligned with the rest of your business. And also underlying this, you need to really think about the energy footprint, because the energy is also costly. So whatever AI factory you're standing up, if it's your own, if you're leaning on some partner, or if you're leaning on Barriet, the energy calculation is super important as well. But if we get all of this aligned, if we set the strategy for this, if we realize the importance of thinking in terms of tokens, if we look at the need for having a sound financial basis for our compute, and if we have a awareness of the factory as a method for producing reliable outputs, then we can actually succeed with our agentic AI. And we can travel the digital world together with our now trusted AI sidekicks, the agents, and be successful. And with that, I say thank you.